possibility that humans will move to Mars in the next 10 to 20 years, I think is something we can put money on. So I believe, and you can wait 10 to 20 years to see whether I'm correct, that people will be living on Mars within 20 years. This is a unique point in history because if we look at the fossil record, life on Earth has been emerging for around 4 billion years. Through the fossil record, we have evidence of early life forms as long ago as 3.5 billion years, tentative evidence of 3.8, and some new evidence of 4.1. So let's say 4 billion years life has been living on planet Earth. It's taken 4 billion years for living organisms to evolve from single-celled bacterial type organisms to Homo sapiens, which most of us here are. For the first time in the history of life on Earth, a species, Homo sapiens, has developed the capacity to come up with a proposal to take a team of people, and not only people, but the food, the seeds that we'll need to eat, the bacteria that helps us digest our food in our bodies. I mean, did you know that 90% of the cells in your body are actually not human cells, they're bacterial cells? So it's not just that we're moving humans, you can Google that, it's true. I showed it to my class the other day. So it's not just humans that will be moving to Mars, it's a kind of ecosystem of life forms that have lived on Earth for their entire existence. So all of our memories, everything all of us have ever known have all been on this planet. And for the very first time in history, the possibility to move this collective memory, consciousness, being from Earth to another planet is happening. So the big picture. As a researcher in quantum physics, also in quantum biology, and also in astrobiology, I would just like to, in 3 slides, share this big picture with you, which goes from the very small to the very big. But I think at this point in history, we are not only capable of seeing the big picture. I mean, for everyone who has a smartphone, that is not only your Uber ride home or whatever, that's also the sum of human knowledge in your hand. You have access to the sum of human knowledge in your hand. Okay, of course there's some things that we can't store electronically, but it's pretty close to it in terms of what we have access to on the internet. So we don't only have the ability to see the big picture, but we have the necessity to see the big picture. Now more than ever, it's becoming clear that our resources on this planet are finite, and that we cannot live our lives without finding the justifications of people and beings that will hopefully continue existing on this planet. And I think it's imperative that we think about the big picture. So in my mind, at least, the big picture means thinking objectively. So not many of us have had the privilege of seeing Earth from this perspective. But people who have been to space, there are only 580 something of them in total in history who have ever been to space. These people have had the opportunity to look back on Earth with a more subjective point of view, and many people have written and spoken about this. You can Google it. So at the moment, these are the 7 people left on the planet Earth who have stepped on the moon. You might notice they are not as young as they once were when they stepped on the moon. So this is actually a tragedy in my opinion. What has happened in the intermediate time between when these men stepped on the moon, stepped on the moon, and now? Why have we not sent people to explore? Will this be the furthest that we've ever been? These guys are all in their 80s. We're trying to raise funds at the moment to bring Buzz Aldrin over later this year. This would probably be the last opportunity to do so because he's now 86. He is doing a huge job for promoting space exploration at the moment. You might want to read his latest book, Mission to Mars. And in a few, let's say 10 years, these guys are not going to be around anymore. Is that really a world we want to live in, where the furthest that people have ever, or the people that have been the furthest are all gone? So I think we can remedy this, and I think we are living in a new era of innovation in space exploration, which I will get to, and I hope you will agree with me by the end of the talk. But that's kind of the big picture, but let me tell you how big the picture is by first going very small. So quantum mechanics does have something to do with this all. And that's my field of research. So what is quantum mechanics? Well, it's the laws that, according to which small particles behave. So how small are these particles? Well, you start with a sugar cube, which is like a centimeter. Then you've got the sand, like a millimeter. That next object is a human hair, which of course we can see. It's not a quantum object. It can't be in 2 places at once. You can touch it with your hands, you can see it with your eyes. But somehow when we go 1,000 times smaller than that human hair, and we get down to the level of DNA molecules, which are just a few nanometers wide, meters long, but a few nanometers wide. Now the strange, bizarre, however you want to call them, laws of quantum mechanics start to play a role. When we get down to the size of atoms, which is the next size down, that's 10 times smaller than a nanometer. These are the kind of scales where atoms exist. Atoms obviously interact with each other and exchange electrons, and mechanics applies. So actually life sits in a very interesting intermediate point where both classical and quantum physics can play a role. And this is a field proposed in the early 1900s that's now gaining momentum, simply because we now have the power to image these very small things in a way that we can sort of study them mathematically. Like this, the ability to image DNA was only achieved in 1953, 53. So it's fairly recent relatively that we've actually known of the existence of these things, and even more recently that we're trying to understand them. So quantum biology involves the fact that quantum effects play a role in living systems. So yes, this is a singing bird that can do mathematics. No. so this represents the fact that there's the proposal that birds navigate in the Earth's magnetic field using quantum mechanics. So basically no experiment done on birds that can navigate in the magnetic field have shown this theory to be incorrect. I wouldn't say there's been a definitive theory to prove it correct either, but it's an exciting topic of research that many people are involved in, involving like 2 electrons that are emitted from a certain molecule in a bird, a brain or eye of a bird, we're not sure exactly which then orientate themselves in the magnetic field of the Earth, which is relatively weak, and that's why we're studying this kind of thing. You can imagine technologies of sensing magnetic fields that become even more sensitive to electrons being emitted and allowing the organism to orientate itself in the magnetic field as a result. So that's a less well-established part of quantum biology. The mainstream view of photosynthesis is that we can't understand the very early stages of photosynthesis without using quantum mechanics. Very early stages means the first millionth of a second. So I think you can understand now why we've only recently been able to really probe these kind of very quick phenomena using ultra-fast spectroscopy, which just takes like photos basically extremely quickly so we can see what's in of the processes, because quantum mechanical effects are at play. So you can imagine the applications for this in terms of developing biologically inspired quantum sunlight harvesting technologies that can outperform currently existing solar cells, which only operate with like 10 to 20% efficiency. In the laboratory, we can get it up to 50%. We're still not doing as well as bacteria. Is that because they've been around for so long? Well, maybe not, because they've been using quantum mechanics since the beginning, as far as we can understand. And this leads me to an even more interesting question. So the technologies are necessary and all very well, but for me as a theorist, I'm always looking at the next question. And for me, if the very first living organisms used quantum mechanics to, forge their path in life on this planet and do so successfully, then can we use quantum mechanics to understand how these life forms emerged? Because this is one of the biggest questions we have. What is life? Where did it come from? How did it start? What is a living system? So to put it in a nutshell, what makes a bunch of molecules different from the system made up of those molecules? Like, let's say I gave you infinite money, infinite students, and an infinitely great laboratory, everything you want. And I told you could order the exact composition of the human body: hydrogen, oxygen, carbon, nitrogen, all the stuff that's in the body, all the metals, and so on and so on. Would you be able to synthesize a human being? Okay, you could say, Mary Shelley has discussed that at length. Yes, great story, but nobody's done it. Nobody's actually managed to synthesize a cell, even just one, from basic components. We've managed to introduce synthetic DNA into an existing cell, but making the cell itself, no, we don't know how. You might think, but we're very technologically advanced, but we don't understand what life is. So one way, scientifically, to improve our knowledge of life would be to find another example of life. Because we're all one example of life. So sometimes when I say we, I mean everything on Earth, because with a 99.279 probability, according to genetics, we're all related. That's all the way from bacteria up to Homo sapiens. We're all related. We share significant parts of our DNA with each other, enough for geneticists to say we all emerged from a single common ancestor. So This is bizarre and has a point. Life emerged on Earth, and that's it. We have nothing else to compare it to. And in terms of coming up with fundamental principles under which life can emerge, we end there. You know, we can study life on Earth as much as we want, but it's probably not going to help us to understand the fundamental principles that lead to the emergence of life. One data point, you can't even really call that science. Emerge would be to find another example of it somewhere else. So where is that somewhere else? Well, the universe is a big place, so the fact that we haven't found evidence of life anywhere yet, at least in the public domain, is not because there's nothing, not because there's no life out there. In my opinion, there probably is, just because the universe is a big place, and we've only become good at looking at faraway places relatively recently. So the points of this slide is to, well, let's go through it. I'm sure you can recognize the first object, Mars. So we're measuring the distances to these objects in light years. So Mars takes about, 10 light minutes. So light takes 10 minutes to get to Mars. That has implications for sending messages to Mars. So one day if I'm on Mars and you tweet something to me, I will only receive it sort of 10 minutes later. So that's a fundamental upper limit. That's the speed that light travels at, which is 300,000 kilometers a second. According to current theoretical physics, nothing can go faster. I hope that that's not going to be the case forever, but that's current theory. So the quickest, or let's look at the nearest star, which is 4 light years away. The most up-to-date information that we have on Proxima Centauri, which is the nearest star, is 4 years old. That's because the light that it's emitting takes 4 years to travel to us. So we're seeing a 4-year-old photograph of what that star looked like. Next, Kepler 452b. So that's an intriguingly Earth-like planet discovered last year. It has goes around its sun in 380 days. Its sun is very similar to Earth. And given those basic parameters, we think that there might be liquid water on the surface as well as an atmosphere, so that's under investigation. 1,400 light years away. So let's say you devised a mission to go and land on Kepler 452b, maybe there's water, maybe there's oxygen, sounds like a great place. Okay, let's get a group of people together. Maybe they're great, let's say you do an intergenerational space travel program. It'll take us about hundreds of thousands of years to get there, depending on your propulsion technology, hundreds of thousands of years. So even when you get there, you'll arrive and you want to send a message home to say you're there safely. 1,400 years for the message. So the possibility of moving to Kepler 452b, not looking good. The nearest galaxy, Andromeda, is 2.5 million, whoops, getting big but not yet, million light years away. And the edge of the observable universe is nearly 50 billion light years away. So those last two, mind-boggling, we can't really encompass them, I think, in our sense of time and direction. But that's the point, the universe is a big place, and this slide is meant to leave you with the message that Mars is both familiar, welcoming, neighborly, and really a nice place to live. So, in case you haven't heard of the Mars One project, here's a video clip which will sort of summarize.
I want to go to Mars not just to be a part of history, but to inspire people around the world.
The colonization of Mars is the adventure of the century.
This is our chance to get the world excited about space again.
If we can look up from Earth and know that human beings are living on another planet, will we ever again be able to tell ourselves that there's anything we can't do?
I want to contribute directly to mankind's confident expansion into the solar system, which we have to do if we're going to survive in the long term.
I believe it is in our nature and it is our destiny.
I want, after I die, the impact of my life is imparted upon those who follow.
I know it comes at the cost of living Earth forever, but future belongs to those who believe in the beauty of their dreams.
So if that's watch something like a trailer or a sensationalist movie, that would be correct. That's actually part of the funding model. So you also might have heard that the people who volunteered are volunteering to leave Earth forever. Yes, there's currently, of course, no rocket technology based on Mars to bring us back, so you could take it with you. But a way to cut corners financially and technologically is to arrive there first and think about developing the technology to come back later. And in terms of being a heavy chef, yes, I am completely prepared to give up my life on Earth for the possibility to contribute to the discovery of evidence of life on Mars. It's a good candidate for having once supported life. And furthermore, establishing life on Mars for the first time from Earth. People often ask me if I have a bucket list. No, if the departure was tomorrow, I would be absolutely ready to go. I don't think having a bucket list is really in the same vein as volunteering for this kind of program. No, there's nothing that I need to do tomorrow except go to Mars if the rocket's leaving. The rocket's not leaving tomorrow. There's still a lot of planning to do. But the program in a nutshell basically aims to settle humans on Mars in a decade. So the departure date is 2026. The technology will be outsourced. So for those skeptics who say that Mars One will not be able to develop the technology to settle humans on Mars in 10 years, you would be correct. They are also aware of this, and therefore they will outsource all technology. So they just need money. How will they raise the money? The idea was initialized actually by the broadcasting revenue of the Olympic Games was around $8 billion during the run-up and during the Olympic Games, simply through broadcasting rights. So the founders of the Mars One project decided that they could raise the money on the order of billions of dollars, of course. That's probably a modest estimate, more like tens or hundreds of billions of dollars. Tens, you might be able to do tens. But they could raise this money through an international media event. So that's the plan. As you saw next year, the 24 will be chosen from the 100, and these people will then be offered full-time contracts with the Mars One project to train for 10 years before departure. You might think 10 years is a long time. Well, it took me 10 years to get my PhD, so I'm completely on board with the fact that these people need to train for 10 years if they're going to come along with me and be my doctor, engineer. Of course, everybody will contribute their own unique skills to the project. So these are the 100, they're from all around the world. I'm really excited to meet them finally next year. I've had some interaction online and I've met some of them in person, but next year will be the first time where we're all flown into a location, we don't know where it is yet, to undergo a 2-week kind of team building task, isolation. It hasn't been very specific what we're going to have to do, but during 2 weeks they will narrow it down to 24. There are 5 South Africans currently in the top 100, which we should be proud of since our population size is much less than 5%. And there are only 2 of us women, and given that they want 50% men and 50% women in the 24, and they want a distribution of people from all backgrounds, continents, etc., I think both of us probably have a good chance of getting through. So we will see some South Africans amongst those 100.